Hi, my name is Chelsea Parlett-Pelleriti, and I want to talk to you a little bit about p-values. I want to tell you how they're a probability, they're sometimes a little perplexing, and they're only part of the big picture. So let's start with the probability part. Say I'm really interested in the height of redwood trees. The distribution on your screen represents the average height of samples of 100 redwood trees. Let's pretend I went on a walk and I randomly selected 100 redwood trees, measured their height, and found the average height of these 100 trees, and it was 350 feet. If you know anything about redwood trees, that's pretty tall, and I might want to quantitatively measure how rare is it for me to go on a walk, randomly sample 100 trees, and find that their average height is 350 feet. Well, that's exactly what your p-value does. A p-value is the probability of getting a sample as or more extreme than the one that you observed. In this case, a sample of 100 trees with an average height of 350 feet. You can see from the shaded part of the distribution that this event is pretty rare, and that's exactly what the p-value tells you. How rare is the event that you observed compared to your distribution? You can see that the probability part of a p-value is pretty straightforward. The part where it gets a little perplexing is when we use p-values in the context of hypothesis testing. Say we have a fertilizer and we think that it increases the height of redwood trees. Well, we might want to test that hypothesis. We could go and fertilize 100 randomly selected redwood trees, come back hundreds of years later, and measure their average height. Our hypothesis is that our fertilizer works and that those trees will be taller than your normal average redwoods. You can see this in the transparent gray distribution on the right-hand side. Just like before, we see that our randomly selected fertilized redwood trees had an average height of 350 feet. Well, what we're going to do is pretend that we live in a world where our fertilizer doesn't work. This is often called the null hypothesis, where there's no difference or no effect. And again, like before, we're going to calculate the probability of observing a sample of 350 feet redwood trees. Again, you can see that with the blue shaded region, it's not really very likely. In fact, it's so unlikely that we're going to act as if our fertilizer does have an effect on the height of redwood trees. In statistical terms, we often call this statistically significant. But even when things are statistically significant, that's not always the whole story. P-values are just a part of the bigger picture here. For instance, we might want to combine p-values with something like an effect size, which tells us the practical significance of the effects that we observe. For instance, if my fertilizer works and is statistically significantly different, well, that's not that big of a deal if my fertilizer only increases the height of redwood trees by an average of 1 centimeter, which in the context of 100-foot trees is really not that big of a deal. However, if my fertilizer increases the average redwood height by 100 feet, that's a pretty big deal and is probably practically significant. So you can see p-values are only part of the picture. We need to combine them with things like effect size to really see what's going on with our data. Thanks so much for watching.